Okay, guys, in this lesson, we're going to learn how to graph linear inequalities instead of just simply linear equations. Graphing a linear inequality is just an extension of graphing a straight line in the form of y equals mx plus b. Just like when we're graphing these linear equations, we have to have the y isolated, and it has to be in this form. So let's review how to isolate y. We're going to add the x terms. We're going to add 2x, and we get 4y is equal to 2x plus 12. Then we're going to divide every term by 4, and we have y is equal to 2 over 4 is 1/2 times x plus 3. So our slope is up 1 and right 2, and our y-intercept is 0, 3. Before we move into a two-variable inequality, let's just recall a single variable inequality and how we graph it on the number line. So we are going to solve our inequality. And we're going to graph. So we have 4. Our solution is greater than 4, and it is not included. So we have an open circle. That means this point 4 is not part of the solution. Then x, my solutions, is greater, so we shade to the right. Here we have our same inequality, except for the symbol is less than. And we have x is less than 4. And when we graph this, again, our boundary number is open because it's not included. Our solution does not include 4. And then we shade to the left because it's less than. So the lower half is shaded. We have the same inequality, but except the symbol is going to be x is greater or equal to 4. So this time, our boundary number 4 is included, so we shade it in, it's closed, and then all the numbers to the right because my solution is greater, so we're going to shade the upper half. Our last example, we're going to have x is less than or equal to 4. Our boundary number 4 is still included because of the equal part. So we do include the boundary number 4, and we shade to the left, the lower half, because of x is less than. So just remember, whenever you have greater or less than without the inequality or without the equal, it is open. When you have the equal sign part of it, it is closed. When you have greater or greater or equal to, you shade to the right, you shade the upper half. So here we shaded the upper part of our graph. And if you have less than or less than equal, you shade the lower half. So let's take a look what it looks like with two variables. So again, we're going to still have our slope that we use in our y-intercept, but notice we either have a dashed line or a solid line. A dashed line means that the points on this line are not included. So look at the dashed line here and here. We do not have the equal part, so you have an open line instead of an open circle. When you have equal, when you have the equal part of it, we have a solid line. All of these ordered pairs are part of the solution set. So that's how you determine what kind of line you have. Then we're either going to shade in the upper part or the lower part. So when you have greater than or greater than equal, when y is greater, my solution y, my outputs, you're going to shade the upper half. In this pink area, you can see we shaded above the line, the upper half. When it's less than or equal, that says my solution, my output y, is in the lower half of the graph, the lower region below your boundary line. So here's our conclusion. So pause the video and jot this in your notes. Now let's try some examples. The first thing we need to notice is this is in slope-intercept form, so we can easily identify our slope of -3/2, and our y-intercept is 0, 4. We're going to plot 0, 4. We're going to go down 1, 2, 3, and to the right 1, 2. I'm going to plot another point. I'm going to reverse my slope up 1, 2, 3, and to the left 2. Before I draw my line, I need to notice if it's going to be open or closed. This is open, so I have an open line, a dashed line. Now I need to shade either the region, the upper part, or the lower part. It says y is less, so we're going to shade the lower part. So I'm shading down below from the boundary line and down. All of these ordered pairs are my solution. This is in slope-intercept form. I have a slope of -2/3. I have a y-intercept of 0, 1. We're going to plot 3 points. I'm going to start at 0, 1. I'm going to go down 1, 2, and to the right 3. I'm going to start back at 0, 1 and go up 2 and to the left 3. I'm going to pause and check to see if it's open or closed. This is going to be closed. All of these points are included. So those points are part of my solution, plus the region in which we shade. Because it's greater than, we're going to shade in the upper region. We're shading above the line. That is all of my solution set. All of those ordered pairs would make that equation true. We have a slope of -1/4. A y-intercept is 0, -2. We're going to start at -2. We're going to go down 1 and right 4. I can go up 1 and left 4. I'm going to pause to see if it's open or closed. It is open. It is a dashed line. I have some openings in my line. So none of these points are my solution set, but y is greater, so we're going to shade in the upper half. My slope is -5 for graphing purposes. I'm going to put a 1. It starts at 0, 4. So we're going to start at 0, 4. We're going to go down 5 and to the right 1. Or I could go up 5 and left 1. I notice that it is open, so I have a open line. My shading, it says y is greater, so we're going to do the upper region. In this example, we have to solve for y. Again, we want it to be y is equal to mx plus b. Of course, we won't have an equal, we'll have an inequality. So we're going to subtract 2x from both sides. I'm going to be dividing by a negative, so that means we have to flip our inequality. Our slope is 2/1, and our starting point is 0, 3. So up 2 and over 1, or down 2 and left 1. I'm going to pause and notice that it is solid, because so this is a closed boundary line, so all these points are included. And it says y is greater, so the upper half. Let's solve this one. We're going to add 3x. We're dividing by a negative, so we are going to flip to inequality. Our slope is negative 3/2. Our y-intercept is 0, -6. Whoops, got in a hurry there. Don't do that. We're going to start at 0, -6. We're going to go down 1, 2, 3, and to the right 2. Or we could go up 1, 2, 3, and left 2. I'm going to pause to check to see if it's open or closed. This is open. My boundary line. And then it is less than, so we're going to shade the lower half. Lower is for the less than. So all of these order parts are my solution. Here we don't have an x value, we just have y. So remember, this is our horizontal line, so our slope is 0, and our y-intercept is 0, -4. So I'm going to plot 0, -4, and just a few other points to make it horizontal. It is going to be open. And it says y is less, so that's the lower half. Here we have another horizontal line, a slope of 0, and our y-intercept is 0, 1. We have the equal part, so this is closed, so we have a solid line. It says y is greater, so we're going to shade the upper region. Here we have a vertical line, so our slope is undefined. We're not going to have a y-intercept. It's not going to pass through the y-axis. It is going to be the vertical line that passes through -4. So just going to plot a few points. I notice that it is open. So that means we have an open line, a dashed line. And it says x is less. So because we have a vertical, less is going to be to the left. These values are less than the ones on the right. We have another vertical line, so our slope is undefined. We do not have a y-intercept. My vertical line is going through where x is 1. This is going to be closed, so it is solid. And my x values are greater or equal to that line, so greater would be going toward the right. All these values are greater than the ones on the left. Now let's write an inequality. So let's find the slope first. So here's a nice point, and here's another nice point. So my slope is up 1, 2, and over 1. So my slope is 2. My y-intercept is 0, 1. It's passing through 0, 1. So we have y. Now, our boundary line is open, so it's not going to have the equal. This is shaded in the upper region, so it's greater than. My slope is 2x plus 1. Here, let's find our slope. Here's a nice point. Look very here, and here's 1. So we're going to go up 1, 2, 3, 4, 5, 6, 7, and over to the right 1, 2, and 3. So our slope is 7/3. It passes through 0, 2 on the y-axis. So we have y. Okay, our line is solid, so we will have the equal to. And the shading is in the lower half. I'm going downward from the boundary line, so it's less than. And then we have our slope of 7/3 times x plus 2. Our slope here, here's a nice point. And right here. So I'm going up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So my slope is 4/5, and it passes through 0, -3. We have y. My line is solid. It includes those points. We have equal. My shading is in the upper half, so it's greater than. Here, let's find our slope. We're going down 1 and to the right 2. So -1/2, and it passes through 0, 1. Y. We have an open, so we don't have the equal. Our shading's in the lower half, so that's less. My slope is -1/2 times x plus 1. I hope this helps.